In this video tutorial, you are going to learn how to use the native tools in QGIS to process LiDAR data. What it means? It means that now in QGIS, we have some tools that come by default with the software. These tools appears first time in the version 3.20. Then it means that from the version 3.20, we can process LiDAR data in QGIS without needing to use any external plugin or tool like LAS tools. In this case, we can work with LiDAR data natively in QGIS. As you can see here, I'm using the version 3.34. Then in this version, when you add here cloud, you are going to see that we have these three tools: point cloud conversion, point cloud data management, and point cloud extraction. With these three tools, we can manipulate a LiDAR data in QGIS natively. Let's go to start. Hello and welcome back to the QGIS Geo-Mapping Master Class, a free course offered by the Geo RGB community. I am Marcel, a hydrogeologist, and I'm the main instructor of this course. This is the 6th lesson of the course and is going to be the last lesson. The topic for today is the 3D geological model using LiDAR data natively with QGIS. The first thing I'm going to do is to download the LiDAR data for this area. Then I'm going to use the website known as the Cartographic and Geological Institute of Catalonia. If you go here to the translation, it doesn't work really well. Then what we are going to do is just leave the native language of the page and go to here and select translate from Catalan to English, then translate, and that one is the best way to translate the page. To download the LiDAR data, you don't need to register, you don't need to do anything like that, okay? Just go to Geo Information and Maps, click over here, and click on Data and Products. Then again, if you want to translate the page, I'm using Mozilla. Then go here, translate, and translate to English, and here we're going to use the elevations. Again, if you want to know the information, you can translate the page. But in this case, what we're going to use is data LiDAR. Then click here. Again, we can translate the page. And as you can see, here we have two different kinds of information. First, we have all these files. That is data, LiDAR data collected between 2008 and 2011. And then we have the updated information. These second files are data between 2016 and 2017. That's the most updated one. Then if we want to use that one, what we have to do is to click on this one over here, the second coverage. Then click here. In this case, we can translate the page again. And what we're going to do is select the square over here and bring that one to the area. That is where we're going to do the geological three-dimensional map. Here, I know already that the information that we need is 4 sheets. Is this 4 over here. Then you place the square over here, and as you can see, that one has been marked with a different color. Then what you need to do is just press download. You can see over here that the file that you are going to download is a LAT. Then click this option over here. And if you click over here, you are going to download the files. I did already, and I have a folder with those files. Is this folder over here. Now you can click right on your mouse and select extract here. And that's the 4 sheets that we downloaded. Next step is to load the files on QGIS. I'm going to minimize the screen, and I'm going to take this one, and I'm going to drop inside the QGIS. As you can see, now is downloading the data. You can see the progress bar here at the bottom. And that file is going to cover all this area over here. It's going to take a little bit of time to load the data. I'm going to pass the video faster. The LiDAR data has already been loaded. Also, you can load the files using this option over here. Select point cloud and then look for the files here with the browser. But the other option is faster for me. Then I'm going to load the rest of the files. It's going to be these 3 files, but I'm going to pass the video faster. We can close this one here and start to work with the LiDAR data. Then here we can take this one, this one, this one, and this one. As you can see, there are 4 sheets. Also, the LiDAR data has already been classified. As you can see, we have different types of classification: ground, low vegetation, medium vegetation, high vegetation, buildings, and etc. And if we want, we can take the points of information and just leave what we want. In this case, this information just corresponds to the ground elevation. Then if we want just the low vegetation, we can select this one. This LiDAR data means that has been already processed to have the information for these different types of elevation. Now we are going to see the cloud of points in 3D. To do that one, we are going to select all the files again to see all the area. And we are going to go to View and select 3D Map Views. We can maximize these windows. Now, using the different buttons of your mouse and also the scroll wheel, you can play to have different views of the cloud of points. As you can see, we can do zoom, we can rotate, and we can move in general. Then we can close this one.
Are you still using spreadsheets for soil and groundwater analysis? If so, it's like you're operating with technology from the Mesozoic era. In that case, you're basically a dinosaur in the digital age. Are you ready to step into the AI era and leverage cutting-edge tech? It might be the perfect moment to explore Geo RGB's revolutionary tool for lab sample analysis. This online application is a game changer, streamlining your process to slash hours and manpower in report generation, while dramatically cutting down on human error in data analysis. Simplify your workflow with technology designed to make your job easier. Discover how simple it is to elevate your lab analysis game. Click the link in the video description or head over to the Geo RGB community website at geescourse.online. Navigate to the Geoscience Apps section, select GeoSample Pro Analyzer, and dive into our easy-to-follow tutorial video. Your journey to smarter lab work begins here.
And if we want to recover the view, we can go to View, Maps, select this one, but it doesn't work. As you can see, at least for me, it's not working. Then what I'm going to do is to go again to Views, select 3D Map Views, and go to Manage 3D Map Views. Select this one because we are not going to use it more, and remove. OK, and close. And now we can open a new view, 3D Maps, new view. And I would like to work a little bit with the toolbars that we have here at the top. This one is for center the map. This one is for taking this one out to have a full screen, as you can see. This one is for having information about the cloud of points. For example, if I select this tool and I select this point over here, but you are going to see this one over here. Then if I select this point, it's going to provide me information about the point. Then let's go to click here, and here you have the information. Then we can close this one here. Go again to here. Here this tool is to measure distance. Here is for just creating an animation. Here is for save as an image. Here is for export the 3D scene. This option is for set view sim. Here we have different tools that we can select over here to have different views on the cloud of points. And the last one is to dock 3D map views. But the important thing here is that when we make change on this panel over here, the new setup is going to be reflected in the 3D map. Then, for example, as we know already that we have too many noise here for the red dots and also the black ones, what we are going to do is to remove these points from the scene. Then what we have to do is taking all these points out from each of the sheets to remove the noise and see again the 3D model. Now what we have is this one. Let's go to the scene. Let's go to center the map, and we no longer have the noise on the cloud of points. Now we have just the information that we selected. Now we can close the view and start to process the LiDAR data. The first thing I'm going to do is to join the 4 sheets just to have one. To do that one, we are going to go here, Point Cloud Data Management, and select Merge. Double click to open this one, and press this option over here to select the ones you want to join. It's going to be these 4 here, and now you can press this button to select where you want to save the new file. Then save to the file, and I'm going to save in this folder with the name LiDAR Full. Then save. But as you can see, when we save here, the format is LAS, finishing with the letter S. However, when we downloaded the LiDAR data from the website, we downloaded it in the format that it was LAS, finishing with the letter zeta. It means that the file that we downloaded, it was compressed. And when we open in QGIS, the software automatically decompress the file and convert that one in a LAS, finishing with the letter S. Now that we are going to join all the files, the final format that we are going to have is a format that is totally decompressed, and it's more easy to use it because we don't have to decompress the file, okay? That's the difference between LAS finishing with zeta and LAS finishing with S. Then you can run, and the process is going to take you some time. Then I'm going to pass the video faster. The process already has been completed. Then we can close this one here, but now it's loading the LiDAR data. Then if we take this one out, we're going to see that now we have all this square that it represents the 4 sheets that has been added together. And it's going to be this file over here, but now it's loading the LiDAR data. Now the new information is this one, has been loaded. Now we can cut this file according to the area of the cartography. Then to do that one, we are going to use the clip tool. But first we need to load the shapefile corresponding to the cartography area, because we're going to use that shapefile to cut the LiDAR information. Then let's go here. Let's go to select vector and click here to look for that shapefile. In this case, I have the shapefile inside the folder, this folder, and is this shapefile, cartography area. Then open and add and close. Then go to clip, double click to open. Input layer is going to be the LiDAR full. Clipping polygons is going to be the cartography area. And now we want to save the new file that is going to be creating for the LiDAR information. Click this option over here, save to file, and we are going to save here as a LiDAR clip. Then save and run. Again, the process has been completed. We can close this window, but the data is being loading. Then we can take this one out, and we can take this one out. And now we are working just with the area designated with the dashed red line. Now we can take this one out also, because we don't want to see the symbology. And that's the new data with the information only in the cartography area. If we go again to view 3D, and we are going to create a second view, this one is the new file. Because we don't want to work with all the information, it's not necessary. We want to work with a small file. Now we can take the layers that we are not going to use. This one is not going to be used, then we can remove it from here. Also this one, I'm going to leave this one at the moment, but I'm going to remove these ones here. The 4 initial sheets that we was using for the LiDAR data. And this one is the last one. Now the next step is to take this file, and we are going to export the LiDAR information, but only associated with the ground. To do that one, we are going to use a new tool. In this case, we are going to go to Point Cloud Extraction, and we are going to select Filter. Double click to open. Here is going to be the file that we are going to use, is this one, LiDAR clip. Then here we have to add the filter expression. Then click this option over here. And if you go here to return number, sorry, let me see, not this one. Here in classification, you are going to see, let me remove this one, that in classification for ground is the number 2. That's the number that we want to add at the filter expression to filter the information of this LiDAR, just to get the ground points. Then here we are going to add this expression that is classifying according just to the number 2, that is the ground. Then OK. And now we can save this one again in this folder. But this one is going to be LiDAR class, indicating that has been classified already by the ground information. Then save and run. The process has been completed. We can close this window, and now it's loading the new data. If we take this one, now the information that we have for the LiDAR is just the ground. Then again, we can go here to view, and we can press this option, and here we have just the model for the ground. this is the LiDAR points, but just only the ground, because we classify the information, and we are going to use this file to do the digital elevation model. Because if we are using this one, let me show you the view again. If we are using this one is not a digital elevation model, because this one is taking also the vegetation, the buildings, and is going to be a model related with the surface, but not with the ground. And what we want to do is just to use the ground information. That's because we are going to use this file, and we are not going to use this one over here. Now, to create the digital elevation model, we need to pass this format to a raster file. Then how we are going to do that one? Using this tool over here, point cloud conversion. Here we have several options, but the ones we are interested is export to a raster, and there are two options. And we are going to use export to raster using triangulation. Why we are not using this one? Because this one is not going to interpolate. As you can see, between the points, we have no information. And what this tool is going to do is just create a raster where we have the point information. But when we don't have any point information, this one is not going to create a pixel for the raster image. However, this one is going to interpolate the information in those locations where we don't have any cloud of points. In these areas where the color is white, we don't have information. Then we have to interpolate the information in those areas. Then how this tool is going to do that one? Using the triangulation interpolation. And that's the method that we want to use. Then double click to open. Let's go to add the information. First, the input layer. Here we are going to add the LiDAR classified, this LiDAR with the ground information only. Then for the resolution of the density raster, set it to 1 meter. This matches the average spacing of the LiDAR data with a density of 0.5 points per square meter, ensuring good detail. Optionally, you can use 0.5 meters for high detail or 2 meters for faster processing. But in this case, we don't have too many points of information, right? Then 1 meter pixel resolution is okay. Then in this case, at the final raster, what we're going to have is each pixel is going to be 1 meter by 1 meter. Remember that when we downloaded the LiDAR data, we saw that information. You can see over here. Density, minimum density is 0.5 points per square meter. Then for the next parameter, for the tile size parallel runs, set it to 500 meters. This provides a balance between efficient parallel processing and memory management. If your system has high resources, you can go up to 1000 meters. If you encounter memory issues, reduce it to 200 meters. In my case, I have a good computer, then 1000 is going to be okay. Then press this option to save the file. In this case, I'm going to save the file in this folder, and I'm going to call this one as a raster LiDAR. And the format is going to be saved, is going to be a TIFF file. Then save, and we can run that one. As you can see, the process goes very fast because we don't have a lot of points of information. Then that's the reason because I can set up the tile size parallel runs to 1000. And now if we may zoom here, I would like to see 1 pixel to see if I can measure the pixels, but it's hard because you cannot see just 1 pixel, right? Okay, it doesn't matter. But you know, the way we interpolate this one, it was just for 1 meter each pixel. Now we can also view the digital elevation model in 3D. To do that one, go to View, 3D map view, new 3D map view. Then here, if you now try to move this one, you are going to see that is totally flat. Then to change that one, you have to go here, to go to configure, to this panel over here, and then select terrain. And here you are going to select DEM, Digital Elevation Model, raster layer. Then here, an elevation layer must be selected for a DEM terrain. Then go here, elevation, and select the layer. In this case, is this layer, raster LiDAR. And here you can modify these parameters. Apply. Okay, and now let's go to center the image. And now, as you can see, we have the model in 3D. We have now a raster file that is a 3D model. Now we can work with this file to create the 3D geological model. Let's go to close this one. I took a break for a few hours. Then when I came back to work again with the project, I realized that something was wrong. I'm going to show you. If I want to create a new view with the raster file again, the information is showing here properly, right? But when I try to create the 3D model, let me show you, configure, we are going to do the same as we did previously. Raster LiDAR and apply, the information disappears. And if I try to center, nothing happens. It's like the tool is not working now. Then I was, restarting the project, it doesn't work, restarted the computer, and load the project again, and it doesn't work. And finally, what I did is to remove this file, okay, and load again the raster file. And that's the only way it starts to work properly again. Sometimes these kind of things happen, and to realize what is the problem is so complicated and very time consuming, right? Now let me show you. Okay, we are here. It is totally flat. Then we go here, configure, then raster, apply, and okay. And as you can see, now it is working properly again. But it took me, a bunch of minutes to see how to fix the problem. Now you know how to fix it, it also happens to you. Now the next step is to convert this raster file to a hail shale map. To do that one, click right on your mouse, go to Properties. Here at the top, Render Type, we are going to select this option over here. And we're going to leave the values by default and apply. Okay. And we're going to use this map as the base map for the 3D geological model. But you can use any base map. In this case, we are going to use this one. But you can use the satellite imagery, the topographic map. It depends what you want to show in your project. Another interesting thing here is this feature over here. It is clear that this part of the raster file, it's not a ground. Looks like it is a building. Then we have to assume that in this case, the classification of the LiDAR data for the ground in this area was not good. Then we have to manipulate the LiDAR data in order to leave this area flat. But that one could be part of a different project, right? How to manipulate the LiDAR data to get the information that we really need, right? In this case, for example, if we remove these points over here and we leave the interpolation to do its job, we are going to see that at the end, this area is going to be marked as a flat area, not with this kind of feature over here. Also, we have this thing over here that I'm not sure what could be. Maybe there is also a wrong point over here that is making this kind of feature here that it's not associated with the ground, right? But as I said, that could be part of a different project. Now we are going to create a new view. Again, this one. But we are going to increase this one to 64. Apply and OK. Now we have the 3D model for the hill-shaped map. Then what I'm going to do now is to add the geology map on the top. Then to do that one, we have to take this one and move this one to the bottom over here. Just over here. We want to have the geological units, the bearing, and the geological context on the top. We are here, and now we are going to mark this one. Also this one. Let's see if everything is until this point correct. As you can see, it is good. And now we want to add the geological context. Then we want to mark this one and see if everything is working properly. As you can see, everything is okay. Now we can see the geological model in 3 dimensions, but we can improve this one a little bit. We can make the geological units a little bit more transparent. Then we are going to go here. This one, the units, properties. Then go here to layer rendering, as you can see, layer rendering. And here we can mark this one to 50%. Apply and OK. Now this one is a little bit more transparent. And I believe in the map, it looks even better because we can see the hill shade even better to see the morphology of the area. Let me move this one a little bit to here. That it depends on you, right? What you want at the end. What colors, what is the transparency you want. Also, if you want, you can add here the satellite imagery. Let's go to load that one. Web, quick map services, Google, and I'm going to select the Google satellite. And I'm going to place the Google satellite just here on the top of the raster LiDAR, right there. Now at the bottom, what we have is the satellite imagery. And we can see that one here. Or maybe no. I cannot see at the moment. Let me see. How I can do this one. If I take this one out, now we can see the satellite imagery on the bottom, as you can see. And the weird structure, as you can see, is this one over here. Here you can see that that one is a building. And also, if you want, you can add the contour lines associated with the altitude. We have that information because at the second lesson, we downloaded all the vector information. Then you can add here on the top, if you want, the contour lines. But also, let me add the topography raster map. What we're going to do is go here, select the folder. In this case, it's this folder, and I'm going to add the raster topography map in the project. Add and close. And I want this one right there, but I want to take this one out. Let me see how it looks like. There we go. Here in this 3D model, as a base map, what we have is the raster topographic map. And the raster topography map, you can see really well. Even you can see the contour lines here. But I don't know if we can see the elevation number. In this case, I cannot see really well. But this one, you can see 1,125. This one, 1,100. Then each contour line is 5 meters. You can see the buildings, and at the end is to show you how you can use the geological model on the top and then use different base map to create your 3D model. That's it for today. Thank you very much for watching this video, and see you on the next lesson.